Lesson 13.7. Lesson 13.7, inverse trigonometric functions. Now, today we're going to take a look at the inverses of the trig functions sine and cosine and tangent. And we're going to be introduced to some new notations. And we have to remember inverses and how they worked to do this. Now, when we look at the regular trig functions of sine, cosine, we have a cyclical sine wave here, meaning it repeats itself. We learned that in our last lesson. And it passes the vertical line test. Sine is a function. However, will its inverse be a function? Well, if you remember, the way to test for inverses is to have a horizontal line test. And this one definitely does not pass the horizontal line test. So its inverse would not be a function. And that's the graph on the right here. So again, once we flip it, and we would have, then we could give it the vertical line test and see that it does not fail there either. So how do you make an inverse of a function also be a function? And this is where we have to modify this graph. So if you look at the graph and you say, well, it's not a function because it repeats, what we're going to have to do is we're going to have to cut it off so that it doesn't repeat. Now, I have to cut it off so it does pass the vertical line test. And for sine, what you're going to do is you're going to cut it off from here to here. And you can cut off anywhere, but this is where they're going to cut it off for our assignments. And if you notice then, if you cut it off top and bottom, you have a function, an inverse, that passes the vertical line test if you only look at that part. Alright, now cosine, sine, and tangent have different pieces that they take. And that is right here. What pieces do you take for it to be a function? Now sine, as you saw, went from negative pi over 2 to pi over 2. And if you change that to degrees, that would be negative 90 degrees up to a positive 90 degrees. Cosine, if you remember, was shifted over a little bit, so the piece that they use for cosine is 0 to pi, or 0 to 180 degrees. Tangent, as you'll notice, has the same as sine. So again, in degrees, it would be negative 90 to 90 degrees. So that is our window. That is what we're going to look for our answers. Now, notation is going to change a little bit here. When do they want to know or use this limited window? And the way they tell you that is by the notation arc sine, arc cosine, arc tangent, or capital sine inverse, capital S, or capital C, cosine inverse, and capital T, tangent inverse. Again, these represent the same thing, but because they say arctan, or they say capital T for tangent, or capital S or capital C, when they refer to that, our answers must be within this window. Because if you remember, if you take the cosine inverse of something, in other words, what degree gives you root 2 over 2, for example, you would say, oh, I know that, it's 45 degrees. If you remember, on a unit circle, cosine is root 2 over 2 at 45 degrees. There's a coordinate there, if you remember, on the unit circle. And it's also down here, root 2 over 2. Which one do you take? There's two possible answers. Well, that wouldn't be a function then. If you could have two possible answers, it wouldn't pass the vertical line test, or in this case, the horizontal line test. So that's why they limit cosine between 0 and pi. So that would say you would take the 45 degree only. So we're going to limit ourselves by them telling us they're going to do the inverse functions. So when we get our answers done, we have to double check to make sure they are satisfying this criteria. And they'll let us know when we have to worry about that by either using arc sign notation or arc notation or capital S inverse notation, capital letters. Here again is the key. If you notice, they're taking this column and they are switching, or they're solving for the x. So in other words, if I want to solve for this, I would take sine inverse, capital S now, of both sides, and my sines cancel, and that's how we get that row or that column. Then they state that these two represent the exact same thing. You can have sine inverse or you can have arc sine. They're asking for the same thing with the limitations that we just mentioned. So what does this mean? Well, capital S. When is sine of x root 2 over 2? Well, we mentioned that root 2 over 2, well, that could be 45 degrees, again if you look at your unit circle, or 135 degrees. Both give you root 2 over 2 on the unit circle. But sine, if you remember, sine is between negative 90 to 90. So that would have to be this one only. Because they had capital S, we are limited to this window. Cosine, root 3 over 2. Well, root 3 over 2 is the cosine, the degree or radian that gives you root 3 over 2 for cosine is 30, again on the unit circle, or 330. If you remember, cosine goes from 0 to 180 degrees, or 0 to pi. So 330 wouldn't fit. So you only take the 30. Arc sine represents the same thing as capital S inverse of this. It means the same thing. So what gives you, or so let's take the arc sine of root 2 over 2. Sine inverse of what gives you root 2 over 2? Now, however, they want radians, so let's keep that in mind. Now, root 2 over 2 for sine is 45 degrees. Okay, but it's radians they want, so let's say pi over 4. Now, we could also say 135 degrees, but again, sine is limited to negative 90 to 90, or negative pi over 2 to pi over 2. So we would take 45 degrees, or in this case, since they want radians, pi over 4. And again, the other one is 3 pi over 4, but that's outside the window. Okay? Now I'm going to stop here, and this is going to be the conclusion of 13.7 Part A. And I'll pick it up after this in the next part.